Hi guys, Harpardara here again. Let's talk about something different today. We have been doing a lot of lead coding, and it's time to talk about some things that matter in day-to-day world, which is interviewing. And interviewing is something that is fun, and it keeps your competitive spirits going. So it's definitely something to be always be looking after, going after, and never to shy away from. So I would say in that spirit, I took a interview with one of the famous Silicon Valley companies, and maybe in the course of the this talk, I would tell a little bit more about this company. But it's a very famous company, and they use some of their products are used in self-driving cars and things like that. So in any case, so let's go before I start boring you guys with any unnecessary details. Let's go with what happened during the interview. So I had first of all I had like 5 or 6 interviews during the course of the day, and it started with the first interviewer who was basically a very gentle fellow who started by, because this was a systems kind of interview where you had to know the lower level of the software stack, which is like operating systems, device drivers. So he started by asking me Unix internals concepts, Unix slash Linux, whatever you want to call. So there we have things like we talked about VM, we talked about device drivers, we talked about memory hierarchy in a typical von Neumann kind of architecture. And then we went to the synchronization, the need for synchronization in a multiprocessor system. And I guess we also talked about interrupts and things like that. Then he asked me interesting question, which was link singly this linked list manipulation, Linux kernel style. So as you know, in Linux kernel we have this thing which is you basically pretty much uh, include. So if you have a structure, suppose you had a structure like type def struct uh, something, and then you had bunch of data here, and then you said, and then suppose you wanted to link these objects on a singly linked list. So usually the way it works is you put a next pointer in this, you say that's the usual style, right? And then you build your own linked list. But in Linux kernel, all you do is you just have to embed one of the list head. I think it's you have to embed some list head thing here, and of course you have to have a list.h file included, and magically suddenly you have all the primitives related to the linked list, like walk, front, back, delete element for each entry, blah blah blah. So anyway, that was interesting. So then we talked about something called container of. So they had this concept of like container of macro, which lets you basically, it finds the offset of a member, or actually it tries to find the offset of a overlapping member given the address of the overlapping, I would say, structure here, given the address of the overlapping, given the address of a member of the structure. So that was interesting. I would say this gentleman was very nice, and he. So it was more like conceptual kind of questions. He didn't put me on the spot for any kind of coding or something, which is a double-edged sword, because you may feel that, hey, he didn't put me for coding, so wow, that was nice. I didn't have to use my brain cells for that time, but that's fine. We should never we should never never try to hide from coding. The coding will get you. If you don't go after coding, coding will get you. So it's better to go after coding. So here we are. So that is, now let's go to the number two. So the second interviewer comes in, and by the way, it was all online nowadays. As you know, the world has been completely foobarred by the this virus that we got from our trading partner. But in any case, coming back to the interview number two, it was kind of hard to understand his English. But after asking me some questions on the differences between processes and threads, and need for locks, and in which situations deadlocks can occur, we finally realized that I'm screwing up with the spelling of occurs. I guess occur. Okay, deadlocks can occur. He basically went right into the coding, lead coding, I would say, of coding. And what he asked me was, given a rearrange. Basically, the question was rearrange a singly linked list so that all the odd elements come before all the even elements. So anyway, I tried something. I probably didn't do that well as I was expecting, but I gave that a shot, and we kind of moved on to the next interviewer. I guess we have a 45-minute break at that point we had, and so they were nice in that regard to give a break, because really when you have like 5 or 6 interviewers constantly bombarding you with coding questions, your mind is pretty much fried at the end of the day. And so I would say that it was very nice on their part to give me a 45-minute break. And then the third interview starts, and um, he was all about Python. So he asked me like tons of questions on Python. And these questions were like, for example, sort a dictionary by value. And I forgot, I think, what I did, but basically, I guess I tried to use a sorted. Um, there's an inbuilt Python function, sorted, which basically returns a list. But I guess he wanted dictionary to be kept as it is rather than returning a list. So basically, he wanted to sort the dictionary by value in place. And we did something. Then he asked me some other Python questions, which were pretty much doable, I would say. So no complaints there. He was a very fine and very cheerful and very understanding and very good human being kind of fellow, and things went very well. So then I would say I was a new interview was brought up, and we started with counting the sat bits in an integer, and that this question I would say is the holy grail of interviewing for embedded systems or systems background kind of people, uh, device drivers, register manipulation. So you really got to be able to count your bits in an integer if you really want to have a shot at one of these systems and lower level kind of jobs. So definitely never ever forget to not practice this. There are like bunch of ways to do that, but use the KNR method of optimization, where he basically instead of checking goes by getting rid of the rightmost one bit in the input. So definitely do that because that's definitely interesting. And then we talked about some basic, um, I would say, questions related to I would say networking. For example, how does traceroute work? And this is where you kind of tend to forget. I was able to point out that hey, they use TTL, but TTL uses but how, what are the more details? They need more details. So the details are that the sender sends packets with TTL value increased increment in each subsequent packet. So that way, when the destination replies with ICMP time TTL exceeded message, you get to know who they are. And this way you basically build your paths to the internet, right? So that was one. And other interesting questions that we talked about is that you have how will you debug a situation where you have imagine you have a card which is 10 gig and all you're getting is 6 gig. Imagine you basically see that all you're getting 6 gig. So how do you debug this? So how do you triage this kind of issue? How do you go about finding the bottlenecks? Is this interrupt processing? I mean, it could be anywhere. It could be interrupt processing, packet drops, at transmitter and receiver buffer overflows, things like that. So you should really be able to talk about these things. You should be able to understand how, if you are really going for this kind of job, which is device drivers and this coding and at a very assembly level and C and your operating systems. So you should definitely be able to talk about the issues. I would say the performance issues for a for the device drivers. So, for example, what kind of maximum performance you can get, and if you're not getting, why you're not getting, and those kind of things. So, definitely, I would say check out some resources on the internet, which are used for debugging these kind of problems. So now we go to the. We also I spoke about. I said we use. Basically, they said that and there's something called NAPI in Linux kernel. And what this NAPI does is that as the hardware advanced and we went from fast Ethernet to like 10 gig and 100 gig and 200 gig nowadays, apparently there's a 400 gig Ethernet interface coming up soon. What happens is the kernel is bombarded with interrupts and it wastes too much time in interrupt processing as opposed to processing the real data. And then, so they came up with this NAPI, which is a combination of polling and interrupt. So basically, interrupt, you start by getting interrupted and then you poll rather than waiting for, so interrupt and polling. So definitely know the difference between these things, interrupt polling. And while I am at it, I should also tell you that get your DMA fundamentals in shape, which is things like need for DMA, I would say. DMA can lead to cache coherency issues on. So definitely revise your cache coherency issues. Cache coherence. What is cache coherence? What is cache invalidation? What does CPU do if it has? How do you tell CPU to basically make sure that it only gets the latest data which has been DMA'd into the memory? So that was a very interesting interview, I would say as well. And then we moved to interviewer number 5th, and this um, hero of software engineering, I would say, was quick to lead me to the path to the lead coding. And he basically asked me, after a bunch of questions related to my past experiences in software engineering, he asked me a question which was write a, so this is write a word representation of a integer. So the example here is, suppose you have input would be something like, so input would be something like 543, and then the output should be something like output should be 500, for example. In this case would be like 500 43. So this is a little tricky problem, because first of all, some of the questions I would ask the interviewer is, and I did ask actually, I said, is there any limit on how many the maximum number can be given to me? Because if you don't, then maybe you'll have to have words for like millions and things like that. But if you have only like input up to 1,000, so then you're basically restricted to having the words for thousands and hundreds and things like that. So this was, I tried to do this in Python, but I think I really didn't do it too well. So I wish I had done better, but apparently this kind of problem leads very well to a recursive kind of solution, because you you start by working at the higher digits of 10, like hundreds and thousands, and then you slowly, as you go to the smaller of the number, as you reduce the input to the lower tens of digits. So for example, from 543, suppose you use a Python's divmod function here, function to basically extract 5 and 43, and this can be extracted as a tuple in Python, so that this becomes zeroth element, this becomes the first element. So basically use the 5 to build your this 500 here, and then for 43 you can pass it back to call the function again and let it build. So I guess the issues here is you may have to have a dictionary which has to basically hard code the corresponding names, at least I guess up to 19, and then from 20, 30, you might be able to come up with another pattern. You might need another dictionary for this 20, 30 up to 90, and then after 100 again you may have to do some tricks. So anyway, that didn't go too well, I would say. I kind of messed it up, but that interview ended and I was very glad to see the hero of software engineering leave. And then we went to the hiring manager. Now, you would think that after so much coding, we would have some kind of respite from coding. But uh, hiring manager also couldn't resist the need for coding and challenges, because in Silicon Valley the coding challenges is what keeps people alive. Like, you got to wake up every day, keep thinking of the how to basically rearrange a singly linked list, or how to count the set bits, and can I optimize this or that, and so you're always at your toes. So I would say this hiring manager also couldn't resist the need for coding, and I wonder if he should have been a more of a software developer than using his soft skills to try to manage people. So, well, it is his choice, but basically, after asking a bunch of behavioral questions, so he did ask me behavioral questions, and I was thinking maybe that kind of makes sense. It behooves his software, his managerial position. But then he basically said that given that this company is what it is, he cannot resist asking some kind of technical questions. So, and that technical questions was quite technical in the sense that we had a coding challenge, and that coding challenge was remove all adjacent duplicate characters from a string. And this was some code given in C already. So there was some code given in C where the input function was actually was being passed a pointer uh, to the address of the string. So basically it was kind of a double pointer, and it's kind of a reference to a reference. And I kind of pointed to him that I guess I was thinking on the lines that strings in C are stored at the read-only memory. So if you're going to modify the input string in place, this is probably going to segfault. But I guess if you're passing pointer to pointer, you can always change that and then have your pointer point somewhere else, your pointer in the calling function. So that probably would have been a better approach. But when you have like 6 interviews in a day and people asking you constantly coding questions, feels like you are a monkey, the coding monkey who has to go through many hoops to get their frigging job. So I would say that, well, anyway, this is how it happened. And this, I'm not very sure about. I had kind of mixed feelings whether I want to work at this place, because even the project didn't sound too interesting. Some and so in any case, the interview was done, and I heaved a sigh of relief after 6 hours of constant coding challenges and questions after questions after questions. So that's your typical Silicon Valley interview. I hope you guys enjoyed the video, and I hope it helps you to tackle your interviews in the future, and it gave you some material and some kind of a framework to understand how the interviewing in Silicon Valley basically works. And I wish you all the success in your software design slash implementation careers. And I will see you guys in the next video. Until then, happy interviewing. Bye bye.